Hello everybody. In this video, I want to show you how to use encoders in different use cases to treat your categorical variables. First, I'm going to talk about these encoders on the slides, so in theory, and then in the Python, you're going to see how to apply and use them. So first thing first, why you need to convert and treat your categorical variables? Because most of the time, many algorithms cannot handle them. And the categorical variables are the ones which have the levels inside them. For example, gender, education level, zip code, and other examples. So there are two types of categorical variables. One is ordinal, which means that the feature is having ordinal nature in itself. For example, educational level. We have bachelor degree, master degree, PhD degree, and so on. So the level really matters here. While for nominal variables, the order doesn't matter. For example, list of countries. In most of the cases, having the order in the countries doesn't matter. So selecting the right type of encoder is dependent to the nature of your data. If your variable need to preserve its order, you have to use the specific encoder. If your variable is nominal, preserving the order doesn't matter. So here you can see what are the different type of encoder based on the features that we need to use. Let me zoom a bit more so you can see it better. So in the case that your variable is ordinal, you need to use ordinal encoder. That we will see later on the practical part, how to call them using scikit-learn. Then if your variable is the target variable, which means that we should predict that variable and it has categorical values in it, we have to use label encoder in order to convert it. For the nominal variable, there are different types that here we will see Onehot encoder, binary encoder, and target encoder. So let's go to the ordinal encoder. So for example, we have different education level in our data: bachelor, master, PhD, and postdoctorate. In order to preserve the order, we can convert them into the ordinal integers. So the lower level is going to be mapped to the 0, while the higher level is going to map to the higher number. As you can see, bachelor is mapped to 0, master to 1, PhD to 2, and postdoctorate to 3. So in this way, our algorithm knows that the higher number, it means that higher value. On the other hand, we have label encoder that we use it to convert the integer. That specifically we have to use this label encoder, as I said, for the target variables. The values will be between 0 and the number of unique categories. So just seeing it by this example, you can see it is exactly like the ordinal encoder, while the label encoder just used for the target variable. So these were easy. Let's go to the other one, which is Onehot encoder, which is among one of the most typical used encoder. So in order to create a Onehot, in order to use it actually, we are converting our levels into the columns, such as Onehot numerical array. So for each level, we are mapping it to a column. And then for each row that contains that level, we are setting 1. So by default, you can, like, as the start, everything is 0. And then for each level that present on the row, as I said, they're going to have, each row is having the 1 for the specific level. So for example, here we have example of Paris, Madrid, Milan, Amsterdam, which are like name of cities in our data. And the equivalent one-hot numerical array is having column. Sorry. So for example, for our first row that has Paris is having 1 on the Paris column, and the rest is staying 0. The second row, which is having Madrid, the second column, which is having Madrid, is going to set as 0, and the rest are going to be 0. And this continues for all of the columns. So what is the problem for this one-hot encoder? If you have many levels on your data, for example, let's say country's name, you may end up with a lot of columns. So in this way, we have the sparsity problem in the data because we have many zeros and many one in the data. In order to convert the data better and reduce the memory consumption, we have to use another type of encoder, which is called binary encoder. So let me show you this example. So binary encoder, as I said, you have to use it when you have many cardinality in your categorical variable. As you can see here, we have many rows with different name of the cities, and you're assigning to each level one number. So for example, here I assign to Paris 1, to Madrid 2, 3 to Milan, and to Amsterdam 4. And as you can see then for the next observation for each categorical variable, each level actually, so we are assigning the same number. So Milan 3, Paris 1, and so on. These numbers are going to be converted to binary strings. Uh, you know how is the binary, I assume. Uh, and as you can see, the 1 is converted to 001, or 2 is converted to 010, 3 is going to be 0111, 011, and continues for the rest. So then these strings is going to be converted to the column. So as you're seeing 001 is converted to 001. This string to 010, and so on for rest of the levels. As you can see, for example, Paris, which is having 1 as the number, it should have the same encoding as well. So I hope uh, the explanation was clear. If not, later we are going to see it also in the practical part. So in this way, you are converting uh, the list of a list that has many levels into 4 or maximum 5 columns. Let's say if your list contains a country list that is 50 or 60 levels, then maximum you're going to create 5 columns for that. In the Python part, you're going to see a real use case on this part, and you will understand better. So as you're saying, this is really memory efficient and it reduced the dimensionality. Another encoder, which is also interesting, is a target encoder. This can be used also when you're dealing with high cardinality features, but you have to be a bit careful for using them because we are going to use target variable to create the encoding because um, we are calculating the number of time that level is occurring in our data and then calculate the probability of its occurrence considering the target variable. So let's see, for example, here we have our rows as the name of the cities, and here we have the target variable, which is a binary problem, such as 1, 1, 0, and so on for the rest of the columns. So this is not converting, so let me delete this one. So these are the features, this is the target. What we are doing is that we are grouping by the levels of the features, and then we are counting the number of times that our feature is having um, the value 1 or 0. As you can see here, Paris is repeated 3 times, so we have totally 3 times as the count. 2 out of the 3 times we have the target variable as 1, so we have 2 target as 1, and 1 we have target as 0. So the probability of seeing that level for target variable is 2 over 3. So we are considering when the target variable is 1. So the probability is around 67. On the other hand, Madrid, as you can see, we have just one observation. So we have one observation, so the count is 1. And for that observation, the target variable that we had is 1. So 1 over 1 is going to be 1. So as you're saying, we are kind of having the leakage problem because we are using the target variable, and if, for example, your training data set is not big, then it can happen that for the future values, you may see a new behavior, or in the future, you can see a new categories, which is not happening in your training data. So these are the problems with this type of encoder, so you have to be careful to use it. In order to solve some part of this problem, there is a method which is called smoothing. With smoothing, you are considering in category average by overall average. As you can see here, I have included a formula which you can find in this link, which I used from Kaggle in order to explain it better. So here we are using the weight of the levels by in category and plus 1 minus weight multiplied by the overall frequency. And the weight is talking about the number of the times that the frequency of the levels which is happening in the data set. So don't worry because here you don't have to implement anything. I'm going to introduce you to a library that you can use directly the target encoder, and you see how you can use it directly. So this is just giving you some idea that you can use also target encoder in order to keep your columns uh, the same number, or yeah, you're not adding extra columns to your data for the training part. So this is helping a lot when you have a lot of levels in your categorical variables. So enough theory. Let me move to the practical part that I'm going to share with you. So here I'm using the Colab in order to explain you the concepts. And I'm using a data set which includes different type of salaries for data scientists. So let me run each of this part. So first I'm loading, then pandas and numpy, and I'm reading my data set. As you can see, my data set is having around 600 observation and 12 columns. So I have extra column which is called unnamed 0, which is just the number of the row. So I'm deleting that one. Just to give you a quick overview of the data, here we have different type of columns. As you can see, we have the work year, the experience level, employment type, it means is it full-time or it's part-time, the job title, the salary, the currency, and so on. So as you can see, our categorical variable is, for example, experience level, job title, employee residence, and company location, or even company size. So we have many categorical variable that we have to take care. So let's say, for example, I do a value counts on the job title. As you can see, we have in this data set, most of the salaries are related to the data scientists, data engineers, and data analysts. And the rest are few observation. And the same, let's go for the experience level. Let me show you the number of categorical variable. Here for the experience level, we have just for level that we have the entry, we have the expert, we have the middle level, and we have the senior level. As you can see, most of the values are distributed among senior level and a medium level. How about company size? The company size is including a small, large, and medium. So most of the salaries are coming from the medium sized companies. So here I'm just splitting my dataset to the training and the I separate also the target column, which is the salary. And so in my X variable, I'm having all of the columns except the salary in the USD. And for the salary part, I'm dropping it since later here I'm assigning it to the target um, variable. So here I will use a category encoder in order to apply some of the encoders that I have explained in the slides. So let's go for the ordinal encoder. One of the variables that we have seen that the order is important is the experience level, right? Because it cares if you are a junior, if you are senior, if you are in medium level. So here, I'm going to use sklearn directly because it has the support for ordinal encoders. So I'm loading my pre-processing library from sklearn, and here I explain what are the levels which are important for me, considering the order. So I start with the entry, medium level, senior, and so on. And then I'm calling the pre-processing ordinal encoder by giving the parameter as the experience level in order to tell to the encoder these are the orders that I want to preserve. And here I just feed the transformers for the column of the experience level. And I keep everything in the expose label. So I directly rewrite the output to the experience level. And here you can see if I do the value counts on the new variable, which is over the experience level, you can see that I have this output. So 2 has 280 observation. For the level 1, I have 230 and so on. So in order to compare it with the previous values, with the original data that we have, as you can see, so the first level that I wanted to keep is the entry level, right? Which is having the 0. I expect to have the 0 as the integer value. So the 0 is here, which has 88 observation, and here our entry level in the original data is having 88 observation as well. So as you're saying, the orders has been kept based on the input data that we gave. So as you see, it's easy to implement this type of encoder by calling the ordinal encoder from the sklearn. So I mentioned also scikit-learn while I meant sklearn, which is the newer version of the scikit-learn. So let's go to the Onehot encoder. So we can use also Onehot encoder from the pre-processing module. So here I use the variable which is having a lot of frequency, a high frequency, uh, not frequency, but a lot of levels on its variable, which is employee residence. So, so it should have the abbreviation of the country that where the company is located. Or it can be, maybe it's not the location, it can be the regions of the US. So here, for example, I have called the Onehot encoder and then I apply fit transform over the employee residence. As you can see, as the output, I have lots of zeros and on the last observation, I have some one. So just to be sure that we applied it correctly, let me first check what are the unique categories that I have. As you can see, these are my unique levels that I have in the employee residence. So now I'm assigning these levels, the output of my one-hot encoder to my original array that I want to see the result. And as you can see, the columns is preserving the previous columns plus the new columns as the uh, as the new columns. So it is including the employee residence value. So here, for example, I didn't drop yet that employee residence because my objective was to show you how to use the one-hot encoder directly. So in the real use case, you have to drop also your categorical variable. And just to give you an overview, you can see for different rows, we will see the output that we can see also here the columns which are added to the data frame. So let's verify, for example, the last two observations that we saw. For example, there are two ones here which are assigned to the US as the columns or the features. So as you see, we have included many new columns into our original data, which is not the best practice because we always try to reduce our dimensionality to train our model. So if we have two or three levels, it shouldn't be any problem. But in such cases, this can be a problem. So that's why I'm calling the binary encoder from the category encoder library. So as the parameters, I'm passing the column that I want to convert, and I fit and do the transform on the training data. And here we can see as the output, instead of having around 60 columns just for the employee residence, we are ending up with just six columns. So as you can see here, the number which is assigned to each employee residence is based on the location. So here we can see the value as the number 1, this is 2, this is 3, this is 4, this is 5, and so on. So the understanding is easy here. Just to be sure, let's, for example, here I keep the still the employee residence just to give you some ideas that like how to compare this column with the new output. So as you can see, we have different employee residence. So this shouldn't be the US regions as we have DE, which can be Germany. And let's search for example, the columns that we have right now, which as we sit together, we have employee residence 0 to employee residence 5 as the new added columns. The number of unique values for employee residence is 57. It makes sense because if we want to create the binary encodings, right, we are going to use till 5, 5 power to power 5 in order to encode the integer variable. So for example, let's see, if I search for the employee residence as DE, here I can see the number of the rows which are including the DE as the employee residence. So let me verify some of the indexes, which is like, for example, 80, 91, and 99, which should include DE as the residence. So as you can see, the DE is having value 1 because as our first observation, we had also the DE as the first, as the employed residence. And as I expect, the binary value for this is going to be 000001. And it is the same for the other observation, which are having the employee residence as DE. So I hope this one is also clear. And as I'm moving to the next and last encoder, which is target encoder. So I'm using still the employee residence as the column that I want to convert. And here I do the fit and transform over my data. And here you can see directly how the employee residence is converted to the a numerical variable because here we have salaries, right, as the target variable. So as you can see, for example, for employee residence with different job title, these are uh, the average, somehow the probability of the job title with a specific employee residence. So to give you a better example as well, I'm going to do the same for job title. So here you can see we have data scientist, machine learning scientist, and so on. So I apply again the target encoder from the category encoder library. And by default, you have the smoothing feature as true. So you don't have to worry about introducing the smoothing feature, which is normalizing the frequency of your category levels over the total observation. And here you can see also for each job title, it is assigned to a specific number, which is calculated as the formula that I have shown to you before. So for example, for each same job level, let's say data scientist, which is this one and this one, we expect to see the same value. So as you can see here, we have the same value for the job title as data scientist, which is directly connected to the target variable. And then at the end, let's say that to be sure, but since the transform, the smoothing function is enabled by default, so we may not see exactly the same result. But here I group by my data set for each job title over the salary target variable. And I calculated the mean. So here you can see the first job title, which is data scientist. It's around exactly the same number, right? As we can see, we saw here that this is the kind of averaged, weighted average of the data scientist over the total observation. And then for the second one, this is so similar because this is not normalized while this is normalized version, but still they are similar. This one is slightly higher, and for this one, this value is also really similar. Still we have some differences. So as you see, here you can convert your string or categorical variable to a numerical one. And yeah, the only problem that you have to be careful about it is the leakage of your target variable on your training data. But if you're aware of this risk, I think then later you will be aware how the prediction is impacted um, on the output of your model. So that's it. I hope that you have learned how to use different type of encoder and where to use them. In the case you have any questions, please leave it on the comments. Thank you.